Okay, welcome to another Ginger Mathematician video. Today we are going to look at 060721, so the May, June 2018. I see my 2.3 version was very popular, so I'm going to go through another walkthrough on this particular paper. With a little twist, I've tried to improve it considering what I did last time. So I have the paper here in front of you, as you can see, but I've also included the mark scheme, so we'll be checking that as we go along, and also what's called the examiner's report as well, which is an important document. It tells you what students did well and what they could have improved on. For example, in this particular paper, that lengthy multiplication or division was not required, and it's often shown you've gone wrong somewhere if you are doing that. Okay. For example, they say that if you're multiplying by 3.142 for pi, that's not the skill they're looking for on a non-calculator paper. Okay. So some general comments. They're saying that generally students did pretty well and attempted most questions and used the correct processes, but there were some basic arithmetic errors in a few questions. I will highlight those as we go, and some sign errors. We're working with algebra as well, so I will point that out as we go along. Okay, so without further ado, let's get started. This is the paper that we're doing. I'll put the full title in the video title on YouTube. Okay, there's the formula sheet, so we will refer back to that for certain questions, but some of these you should know already off by heart. So for example, the sine and cosine rule, more for paper 4 than paper 2. You should try and know that off by heart. Right, so question 1. Work out 5 minus 7 times 2 plus 8. Right, so this is an order of operations question, working with BIDMAS or PEMDAS, so that tells you which one to do first. With this question, have a think. Which operation do you do first? The minus, the times, or the plus? Okay, so we are going to do, first of all, the times, the multiplication. So if we do that, we will get the following. Let me just drag this over. Well, 5 stays the same. Minus 7 times 2 is minus 14, and the plus 8 is still there. And now we work from left to right, working through it nice and carefully, not making any silly errors. So 5 minus 14 is minus 9. Now we deal with the plus 8, and minus 9 plus 8 is equal to minus 1. So the key thing is to do these operations in the correct order. So number 1 is here. We do that part. Then we do it from left to right. So the second part is here. And then last of all, the third part there. And a lot of people got that question wrong. Okay, so the answer is minus 1. Just make sure you do things in the right order. Now this question, according to the examiner's report, many people didn't see the 3 here, and this means the cube root of the particular expression. So we're looking for the cube, trying out the fancy new pad, the cube root of that particular expression. So what the question is essentially asking is something times something times something is equal to 0.001, where these things have to be the same number. Once you think about it like that, then the answer 0.1 comes to mind quite quickly. 0.1 times 0.1 is 0.01, and then 0.01 times 0.1 is 0.001. So just keep working through that kind of question steadily, looking for, is it a square root or is it a cube root? Now question 2, unfortunately, I can't really do on this particular device, but we're looking for the reflex angle. A lot of people made mistakes. They looked for the obtuse angle here and not this angle there. So when you do get an answer, it should be, because the angle is reflex, that the answer should be greater than 180 degrees. Okay, so it should be more than 180 when you measure it. If it's less than 180, you have gone wrong. And if I go now to the answer, question 2, or question 2a, as you can see, some people did the obtuse answer, and the answer to that question is between 232 and 236. Do make sure you're doing it accurately. They're not going to give you much leeway, so much room to work it out. So make sure you do that one absolutely accurately. Now, question B should be something familiar to you. You've got angles in parallel lines, so certain words like alternate and corresponding and interior should come to mind. And if we look at this and we draw over where the angles are, you'll see that we get a backwards C. Now that means, let me just do this quickly, this means these are called interior angles. And the good thing about interior angles, oops, where's that going? Over there. And the thing about interior angles is that they add up to 180 degrees. Now if you just look at this, it doesn't look like this angle is the same. So the angles can't be the same. There must be some other rule. And here, well, 180 minus 80 degrees, well, that will give us then the answer of 100 degrees. So that's our answer for question 2b. Okay, so remember those key ideas: interior, alternate, corresponding. They do come up from time to time on these paper 2s. And the last question, again, it's about reading the question carefully. We're looking for the size of one exterior angle of a polygon. So if you imagine we draw a part of this 18-sided polygon, so I'm just going to draw it roughly like so. What we're looking for essentially, and I'll quickly do a dotted line here, is we're looking for the exterior angle of this polygon. So this part here, okay, so that part of the polygon. And the way to do that is pretty straightforward. So the way you go about doing this is as follows. We take a full turn, because imagine I drew the entire shape all the way round. I would get eventually, as I go all the way round the shape, a full turn. And we know a full turn is 360 degrees. Then we simply divide by the number of sides, and that's 18 in this case, and we can work that out to be 20. Okay, how many 18s fit into 360? Well, that's going to be 20 times. If you find that part tricky, however, you can always use the bus stop method. So, like so, if I draw a quick bus stop, you put the 18 here, you put the 360 here, and you can do the division manually as well. But the answer we're looking for is it's going to be 20 degrees. Okay, so know those words: exterior, interior, and what they mean. So important to get that kind of thing correct. If we go to the mark scheme, always worth checking. You'll see majority answered 2b correctly with interior angles. Some people tried to use the m-2 formula, so m-2 times 180 over 18 formula. That's fine, but you just need to be careful how you sort out the numerator. Okay, so try and avoid those errors by keeping those formulae you've learnt as simple as possible. Okay, so that was question 2. Let's move straight on to question 3. Keep bouncing between these particular places. And we've got a simultaneous equation. This is a situation where we have the x's the same and not the y's the same, but that's absolutely fine. we look at the two signs in front of the x, they're both positive, and because they're the same, we're going to minus the equations from each other. So what we're going to do is we're going to minus the equations from each other. Now x minus x, well that will just be 0, and let's get a text box here. Good. So x minus x is 0. There will be no x's, that's the whole point. Minus 3y minus minus 2y. Well, the minus and the minus makes a plus. So we get the calculation minus 3y plus 2y. And minus 3y plus 2y, well, that's equal to minus y. Okay, so go through that again. Minus 3y minus minus 2y, that becomes minus 3y plus 2y, and minus 3y plus 2y is minus 1y, or minus y. And of course we have to do the same to both sides, so 7 minus 5 equals 2. And I think we can see from that step that if minus y is 2, then y itself must be minus 2, like so. Now we're not finished, we've only got one answer so far, so I can pop that answer in here. So that's minus 2. But we now have to find the other answer. So we substitute the minus 2 back into an equation. And I'm going to put it in equation 2. So we copy out that equation. So we write down the x. Now minus 2y minus 2 times minus 2, well that is positive 4. That's important. I did talk about those arithmetic errors earlier, and that's equal to 5. And I think it's straightforward from here that if x plus 4 is equal to 5, something plus 4 must be 5, therefore x is equal to 1. And therefore those are my two answers. X is 1 and y is minus 2. And quick check on the mark scheme. As you can see, most people recognise to get rid of the x's immediately, but some people found this particular step quite tricky, the two minuses making a plus, then using your number line. So you do need to be careful how you go about doing that. So x is 1, y is minus 2. Okay, so let's get back to question 4. Okay, so we've got some numerical calculations. Well, 0.68 as a fraction in its lowest terms. Well, this 8 that we see here, that's in the hundredths column, if you were to use that kind of diagram. So the fraction then is 68 over 100. However, it wants it in its lowest terms. So that means you need to simplify the fraction, and there are a lot of you out there. I'm just going to keep dividing by 2 until it gets nicer. So let's do that. So 100 divided by 2 is 50. Okay, that was a bit odd. I did that. Is 50. 68 divided by 2, well that's 34. So there's still even numbers, so we can keep going. Let's divide by 2 again. This will give us our answer. So 50 divided by 2, well that's 25. And then 34 divided by 2 is 17. And that can't be simplified any further. Essentially 17 is prime and 25 is less than its next multiple, which is 34. Okay, most of you are probably getting that correct at home. The next question is dividing by fractions. So I use a nice phrase here, and I'll use it as initials. So we keep the first fraction. We switch the divide to a times, and then we flip the last fraction. Not dragging things around. We flip the last fraction. So what does that mean? Well, let's do it. So A little moment to adjust. So we've got 3/7. We've kept that fraction as it is. We've switched the divide to a times. And then finally, we flip the last fraction to get 9/8. Okay, and then we just simply times top times bottom. So 9 times 3 is 27. 8 times 7 is 56. We do a quick check. Can we divide by 2? No. Can we divide by 3? Well, yes here, but not here, because 6 plus 5 is 11. 3 does not go into 11, and I reckon that is our answer. So, quick check of the mark scheme. As always, yep, those are our two answers, and most people answered these questions correctly. So, as long as you know your thing, yep, some people tried to find a common denominator, even though you don't need to for dividing fractions. Okay, and there's the mark scheme as well. Okay, back we go, question 5. Now, this question, some of these numbers should look familiar to you. And if I was to highlight these particular numbers here, 1, 4, and 9, well, what kind of numbers are they? Have a think for 5-10 seconds. Well, if you said square numbers, you'd be absolutely correct. So we have the square numbers here. Now, we can show that in nth term theory as n squared, but we don't start there, do we? We have to think, okay, well, where do we start our square numbers? Well, we actually go back a little bit, don't we? So we've got 0 there, and we've got 1 there as well. So then we think, okay, how many steps am I taking back from the square numbers? Well, I'm taking 2 steps back from the square numbers, so my nth term then would be n itself, which is fine, but then we minus 2 to go back 2 steps in our square number sequence, and then we keep the squared. That's a very nifty way of doing that particular question. There are other methods looking for differences, but I think that's a neat way of answering a nice 2-mark question to get that in the exam. The mark scheme likes that approach, is in leaving it as n minus 2 squared. As you can see, some did it using the simultaneous equation method. As you can see, only a few candidates were successful in doing that approach because it's quite complicated for a 2-mark question to be doing that kind of method. So just looking for that kind of pattern is the way to go on a kind of question like that. But if you wrote anything with n squared, anything, n squared plus 2n, n squared minus 3, whatever, you'll still get a method mark. So keep that in mind. If you see a difference of a different sequence, write down a quadratic, you'll probably get a method mark. So something to learn about. Okay, don't worry about that. They're not trying to come and find me, so it's all good. Right, let's keep moving on. So here we've got an expand and simplify question. So we're going to use a method called FOIL. So we multiply certain things in a certain order. This should be familiar to you. Some people do a box method, but I think FOIL is probably the most straightforward way of doing this. But there are other methods. So we just have to make sure we times everything by everything. So first of all, we're going to do 2p times p. Then we're going to do 2p times q. Then we're going to do minus 7q times p. And then finally minus 7q times q. We get this kind of double hook or eyebrow look to our diagram. So let's go through the actual steps of this, and we might have to simplify afterwards. So 2p times p is 2p squared, which I'm going to write on my lucky keyboard like this. Then 2p times q, well, that's just 2pq. Then minus 7q times p is minus 7pq. Make sure to write them in alphabetical order. And then minus 7q times q is minus 7q squared. Now, remember these middle terms, or cross terms, as people call them, you have to simplify those. So we've got a minus 7pq plus 2pq. Well, 2p squared stays the same. There's my button. Minus 7pq plus 2pq, well that's minus 5pq, and then minus 7q squared. So those are the only terms that you can simplify. So this here, let me underline it, this here is my answer that goes here. Okay, just go through it nice and carefully, make sure you don't make any mistakes when you're working through it for your 2 marks. Okay, the next one is a bit more confusing. This is trying to encourage you to do something called split the term. Okay, so let me write that down. So you're splitting the term. Okay, and what that means is you're going to literally split the expression into 2 parts and factorize each part separately. Okay, so literally imagine we put a line all the way down here, the minus should be on this side, and we are going to factorize. Okay, so the first part starts out relatively straightforwardly. Oops, there we are. So let me move that over here, got a bit of room. So 2 minus t is going to stay as it is. I'm going to put it in brackets though, as you'll see why later. Now, what do these 2 terms have in common? Well, they have an minus, or they have an a in common. We're going to make it minus a, because when you put this into a single bracket, well, what do you multiply minus a by to get minus 2a? Well, just 2. And what do you multiply minus a by to get plus at? Well, we get plus t. And I've just realised that that's not very helpful, is it? Because, no, I'm doing this correct. So that should be minus t, yeah, because minus a times minus t is plus at. I knew I was on the right line here. Okay, so, well, now they've both got a 2 minus t in common. And remember, if there's nothing in front of the bracket, this is just a 1. So what we're going to do now, very sneaky, is we're going to collect up the 2 minus t's together. Whatever we're left with outside the bracket goes in the other bracket. So we get 1 minus a. And that is our answer. So that goes over here. Now, if you don't believe that factorization, well, multiply out the brackets like we did in 6a and check for yourself that that actually works. It's called splitting the term. It doesn't come up that often, but sometimes they'll structure a question in such a way where you have to use that particular method. So it is useful to know. Okay, go back and check the mark schemes, any comments they had there. Let's have a look. So question 6, yeah, they put the brackets the other way around. It makes no difference. Yeah, some people did this part incorrectly. Minus 7pq plus 2pq is actually minus 5pq. So really do remember your negative numbers there. Okay. Yeah, and a lot of candidates actually did recognise that partial factorisation. So well done these people that did this paper in 2018 last year. Well done them. Okay, and that's the mark scheme there. Let me drag it down slightly. Good. Okay, let's move on to the next question. So we're on now to question 7, a circle theorem question, which is nice. Always like these. So, O is the centre of the circle. Find the value of x and the value of y. The first thing to realise in this kind of question, this shape here is not a cyclic quadrilateral. Have a think why. Hopefully you're screaming at the YouTube channel in my videos and you're saying that O is not on the circumference, so therefore this cannot be a cyclic quadrilateral. However, why don't we just draw a cyclic quadrilateral ourselves and actually draw a shape like that and have an angle just up here like that. So this here is a cyclic quadrilateral with this extra shape I've drawn in. Now remember, the angle at the centre is twice the angle at circumference when on the same arc. Therefore, this angle here, and it kind of looks like it, is going to be 70 degrees, like so. And now we can use our cyclic quadrilateral rule. That is, these two angles here, y and 70, have to add up to 180. Therefore, y has to be 110 degrees. Okay, now as you see, I started trying to work out what y was first and not x. It makes no difference. If you see an idea, then try and take it to the full. You'll work out some useful angle somewhere. If we take x, however, well, we notice it's on the same arc, okay, because they share the same arc. So if we go from O outwards and find those 2 points on the circumference, here and here, that's also the same points where this angle x meets the circumference. So this idea of angle at the centre is twice the angle at the circumference also works. So actually these two angles are equal. So angle x is 70 degrees. So nice 2-mark question. No reasons required, just write down the angle. If we go back to the mark scheme, you'll see that some of them didn't apply it correctly. Yeah, so some people thought exactly that x had to be something slightly different. So again, just make sure you know your circle theorems in good depth. And let's move on. So, question 8, this is usually badly done in my experience as teaching iGCSE for a number of years. Y varies inversely as x squared. When x is 3, y is 4, find y in terms of x. Okay, 2 marks, shouldn't be too complicated. So let's go through this. So first of all, we write our proportionality statement. What does that even mean? Well, let's have a look. So y is proportional to, so this weird alpha symbol, x squared. Okay, so that's what it's saying in the question. Y is proportional to x squared. Therefore, we can write a basic equation of y equals some constant k, which we're going to find out very soon, x squared. Okay, very important you write the proportionality statement and then write your basic equation. Now we're going to substitute the values that we do know into that basic equation over there. So when x is 3, well, y is 4. So let's work that out. So let's write down that y, which is 4, is equal to, well, k we don't know, and we need to work out what 3 squared is. Okay, well that means therefore that 4 must equal k times 9, and then we divide by 9 on both sides to find the constant, so k is equal to 4 divided by 9. And we've done what the question wants. Find y in terms of x, where we've worked out this constant, in this case, k. So our answer is y equals 4 over 9 x squared. Now generally these questions have a bit more depth to them, so you have to use this equation to find y when x is something, but 2-mark question is going to be a bit more basic. Question 8 mark scheme, let's have a quick look. And I've made the classic mistake because I did not read the question and it says varies inversely. Did it actually say that? And it does. So what I've done here is I've done y varies, just y varies. Why doesn't y vary inversely? Okay, so there is a slight addition we do to this. In fact, I'm going to have to delete some of this, aren't I? So this is a classic case of reading the question correctly, which is we are looking to do it inversely, not directly. That is an important point. So This equation needs to be adjusted slightly, as our proportionality statement is the following. Well, I'll keep a lot of this already. So y does not vary as x squared, but y goes and varies inversely. Therefore, y is related to 1 over x squared. Okay, this is really the important part of inversely compared to direct. Okay, please watch my YouTube video on this as well. Therefore, it's a very similar procedure, but this time y equals, let's get rid of that, y equals k, so that constant still appears, but this time in the numerator, over x squared. Okay, so y equals k over x squared. And then we do the same procedure of substituting into our formula. So let me drag this over, like so. So we get a very similar equation to what we looked at. 4 equals k divided by x squared. Well, 3 times 3 is 9, so you can see very similar procedure. But now we times by 9 on both sides, giving us k equals 36. And we put that back in our equation over here. So our final answer, zoom in a little bit more so we can see what's going on, is y equals 36 over x squared. That's a classic case of reading the question. And if we go back to the mark scheme, here it is 36 over x squared. No one actually made the mistake I did. Okay, some square rooted at the end, some just had no idea what varies inversely means. So interesting to see that even I, as a maths teacher of many years, make that mistake because I'm not reading the question. Hopefully that gets that point across to you. And the mark scheme is down here. Right, let's carry on. So question 9. So find the value of 27 to the power of 2/3. Okay, so we break this down. If there is a fraction, there will be some kind of root involved. The 3 tells us it's a cube root that we're looking for. So we're going to find the cube root of 27. So that's what the 3 at the bottom stands for. But don't forget the 2 at the top. That tells you to square whatever root you get from that bottom number. So the cube root of 27, so we ask ourselves, something times something times something is 27. What's the something? Well, that's going to be 3. And once we've worked that out, then we square the number, not times by 2, but square it, and we get it equal to 9, like so. Okay, and question 9b. Well, we need to simplify this expression. Remember, we deal with the numbers and the indices, or the little numbers, separately. So, first of all, we do 18 divided by 3. That's going to be equal to 6. And then h to the power of 18 divided by h to the power of 3. Well, then we minus the little numbers, and that gives us h to the power of 15. And we're done. 2 marks, 2 distinct operations going on. Quick check of the mark scheme, as always. Okay, so we have 9, and we've got 6h to the power of 15. As you can see, a lot of people struggle with indices questions and dealing with fractional or negative indices. So something to really revise on those paper 2s. And many candidates struggled written in that particular form, and would have probably found it better if they had written it as a fraction. Okay, that's an interesting point. Didn't really think about that. Okay, so let's carry on. Question 10. That's the mark scheme there. Your benefit. See what's coming. And let's have a look. So v squared equals u squared minus 2as, which you should know from physics, to velocity formula, and then find s in terms of a, u, and v, i.e. we want to make s the subject, and it's a different way of writing for the same thing. So we want to make s the subject. Okay. There's a couple of different ways of approaching this. I like my things being positive generally, so that's how I'm going to approach it. So, first of all, we are going to add 2as to both sides of the equation. So we get 2as plus v squared is equal to u squared. Okay, so I've just added 2as to both sides of the equation, so it has the effect of this coming here and being positive. Now I'm going to take this v squared and bring it to the other side by minusing v squared. So I get, and let me drag this down slightly, 2as is equal to u squared minus v squared. So again, I'm just fiddling around with it, try and keep everything as positive as I can. And now we've got s and 2 here. What's the opposite of timesing by 2 and s? Well, dividing by 2 and s. So we get the answer, I think I'll write this one out as s, wait a minute, as s equals, well, u squared still stays on top, minus v squared here, and then we divide through by the 2 and the s, so we bring that over here. And what we've done on both sides of the equation is that we've divided by 2s on both sides, and this is then our answer that we put into here. Okay, let's check the mark scheme. Any comments about it? So question 10. Oops, I made A the subject. Oh dear. So let me go back. Does help to read the question, doesn't it? So yeah, sorry, this is A. I've divided by 2a on both sides. So this is 2a, sorry. Okay, because I want s as a subject, not a. Okay, so not much to talk about that. Let's go back to what they commented on. Yeah, so doing it in the right order, dividing by 2a too early, making sure you get 2as on its own first, then divide through, not the other way round. Okay, and so there are a few errors there. You can read that through at your leisure where the errors were made. Okay, and that's the mark scheme there. It shows you where you pick up your method marks, like so. Okie doke. So let's move on. Venn diagram question. I'm not a big fan of these, but there we are. That's allowed. So what we're looking for is A union B, okay, or A or B, but not that. Now A or B would be everything in the Venn diagram. So that what would A or B be? However, we want everything that's not that. Therefore, we shade in everything. Let's see if I can shade this in. Shade in everything around the outside. Hopefully, in your exam, you do things in a probably prettier way than what I'm doing. So you want everything outside the Venn diagram because you want not A or B. For the second question, okay, well, let's read it through carefully, doing it one step at a time. So we've got P or Q. Well, that's both of these circles included, and we want R as well. So out of what I'm going around now in my Venn diagram, I want the part that includes R as well. Okay, well, I stop here because I'm now in R. So I want this part. I still want to stay in R. So I want this part as well. Okay, so these are the parts that are in P or Q, but also in R as well. Oh, no, that can stay exactly where it is. And so I want to colour in then everything that lies in this section here. So I colour in that part there. You know what, I'm having great fun here. I'm going to colour it in completely. Oh no, that's too much. Okay, there we are. So read it through carefully, break it down one step at a time in your mind, and then finally colour in the correct part there. Quick look at the mark scheme. Most people did it correctly. The 3 sets obviously cause more problems with the bracket and union to think about, but generally done pretty well. I'd agree that's a pretty nice Venn diagram question to have. There we are, so those are the 2 answers I just shaded in. And let's look then, we're getting towards question 15. Quite a long video, I know, but hey, if you watch 20 minutes, come back, watch another 20 minutes, that's a perfect way of doing it. Okay, so simplify the surd fully. So let's have a look at our surd. We want to find the highest square number that fits into 700. So when I say square numbers, I mean things like 1 times 1 is 1. 1 is a square number. 3 times 3 is 9. 9 is a square number. 4 times 4 is 16. 16 is a square number, and so on. So which is the highest of those kind of numbers that fit into 700? Have a think now. Okay, hopefully you spotted that this can be rewritten then as the square root of 100 times the square root of 7. That key number 100 is our square number that fits in. The square root of 100, of course, well, that's equal to 10. And then the root 7 stays on its own, and we leave it like this. 1 mark, it shouldn't be too complicated a problem. So that gives you your 1 mark. Now, rationalizing the denominator, this keyword rationalize means to make the bottom a whole number. So you want the bottom to be a whole number. So we're going to have to approach this in a very particular way to make it a whole number. And what we're going to do is multiply by its conjugate. What that means is we're going to multiply this by the same thing top and bottom, so it doesn't change what it is. But instead of multiplying by 7 minus root 2, we're going to multiply by, go back in again, 7 plus root 2. Okay, so we're going to multiply by 7 root 2, but remember we're going to do it the same to both the top and the bottom as well. Okay, now let me bring up a text box. If I multiply the bottom by 7 minus root 2, let's write it like this, 7 plus square root 2. Well, we're going to use FOIL like we did before, and watch what happens here. 7 times 7 is 49. 7 times plus square root 2 is plus 7 square root 2. 7 times minus square root 2 is minus 7 square root 2. And then minus root 2 times plus root 2. Well, a minus times a plus is a minus. And square root of 2 times the square root of 2 is 2. And the great thing about multiplying by a conjugate is that these two terms here, these two terms disappear. Because 7 square root 2 minus 7 square root 2 is 0. So all we have to focus on is 49 minus 2. That gives us then that the bottom part is 47. And if you times anything by 1, you just get itself. So this becomes 7 plus root 2. And we're done for our 2 marks. There's some simplifying after. It would probably be a 3-mark question. Okay, mark scheme, always checking. So we get 10 root 7 and 7 plus root 2 over 47. Some people multiplied by the plus version. It's a common mistake made. Or just to multiply by 7 root 2. That's also a common mistake as well. Okay. And yeah, writing these the wrong way round, that is quite common. Or writing it like this, which is not fully simplified. That is also a good point, or just wrong in that case actually. So let's keep moving on. 3 more questions to go. Let's keep moving on forward. So what have we got now? Okay, a factorising question. Simplify fully. Now these kind of questions, they do this on purpose, that when you factorise and put into brackets, that something will simplify. So what we do to start with, and this is a nice sneaky trick to remember, we start with our numerator. So they've both got t in common, so we're going to take a t out. And then we say to ourselves, what do we multiply t by to get 3t? Well, that's going to be 3. What do you multiply t by to get minus t squared? Well, that's minus t. And we factorised into a single bracket. Now, this means at some point we're going to get 3 minus t in one of the brackets. And if you're very paying attention, you'll notice this is a difference of 2 squares. Because they are both square numbers, there is a minus between them. So the square root of 9 is 3. So we set up our brackets like so. The square root of t squared is just t, and because it's the difference of 2 squares, we have 1 minus and 1 plus. So this is called difference of 2 squares. You want to look this up. So d o t. Oh, that's far too far. Let me draw that again. I'm grateful for this trackpad. D T S. If you want to look this up. Now, the reason we've done this is that this cancels with this part here, and therefore we're left with our answer of t over 3 plus t. And we're done. Now, not too much work really for 3 marks, but it's conceptually quite difficult that you're supposed to factorise first of all. The top does go into a single bracket and there is a cancellation. So it's not straightforward by any means. Okay, let's have a look. So question 13. Okay, people that are familiar with the question were able to factorise top and bottom and then cancel. But some try to go a bit further. That's interesting. So some people try to do what's called bad cancellation and remove the t's at this point, which is interesting. Okay, so to get the 3 marks, you need to be confident that this is the answer and there's no common factor. That's because there's a plus here. Okay, if it was 3t and not 3 plus t, then you could simplify in that way. So that's an interesting point to make. Okay, so there's our answer. Let's keep on moving. And there's the mark scheme there as well. You can see what you're getting your marks for. Okay, question 14. Write down the value of log 3 to the base 9. Now, I like to rewrite these to make a bit more sense. Okay. Now, notice our 9 is our base number. So what the question is asking is 9 to the power of something. Let's call that x. So 9 to the power of something is equal to 3. That's a different way of writing that particular question. Okay, now there's a couple of ways of doing this. Some of you might recognise the answer immediately. If not, then I'll do it in a slightly different way. We all know that 9 is the same as 3 squared. So all I'm going to do is rewrite 9 as 3 squared. And don't forget the x has to be put after it. So 3 to the power of 2x is the same as 3 itself, which, remember, 3 on its own is 3 to the power of 1. Therefore, these two things here have to be the same. Therefore, 2x is equal to 1. Now, I'm sure some of you noticed the answer immediately from this step here already, but this step is quite a nice one to do as well. If 2x is equal to 1, then x is equal to a half, or 0.5. Okay, and we've got our answer there. Okay, now question B, we want to find the value of x. Common kind of log question on paper 2. The strategy for this is to convert the left-hand side into 1 log and then just read off what x is. So the way we do that is in 2 main steps. Remember, in logs, you can take the number at the front, that's 2, and bring it as an index here. Okay, so what we get is log 2 squared. Okay, so that's all I'm changing, plus your log 15. Sorry, log 11, sorry. Like so. So all I've done is I've brought the 2 to the back. Now 2 squared is 4, so this becomes log 4 plus log 11. And now remember that very first rule of logs, if you're adding logs, that's the same as multiplying these two numbers together. So this is actually equal to log 4 times 11. Okay, so we can multiply these two numbers together, and therefore we get the answer of log 44, which is simply what x is. So our answer is 44. And we're done. Okay, let's go back and check. There's a half, there's 44. What are the common errors made here? Some people put minuses, that's not so good. Some people actually put the answer as log 44, which is obviously incorrect. The x is 44, not the whole thing. Okay, and some people actually added numbers and not multiplied. Okay, that's interesting to know. Right, question 15 is our last question. And let's have a look here. So, question 15, always tricky. Last question. Length of the arc AB is 4 pi over 3 centimeters. Area of the sector is k pi centimeters squared. Find the value of k. Right, so we're going to need two formulae for this. This is, I think, might be on your formula sheet, but you should know these anyway. The circumference of a circle, or a whole circle, is equal to 2. Get down here. That's it. 2 pi r. That's the circumference all the way around a circle, and the area is equal to pi r squared. Two basic formulae you simply need to know in order to do this question correctly. Okay, so let's see what we can do with this question. And we don't know the angle, which is interesting. They're not giving us the angle of this question. So let's call it something. Let's call the angle, let's call it y for a change. So let's call that y. Right, so let's just put in the formula for the arc length, which will use this formula as well. So let's get a text box to do that. So the length of the arc, well, we know that's 4 pi. I'm going to write it like this, 4 pi divided by 3 is equal to, well, it's the angle over 360. That gives us the proportion of the pi that we have, of the circle that we have. Y over 360 multiplied over 360 times, or 2 pi r. So 2 times pi times r. Okay, going off the page slightly. Right, get over there. That's it. So y over 360 times 2 times pi times r. Okay, and let's see if we can simplify this. So the pi's disappear, and we get a factor of 2 out as well. I might have to write this in pen actually rather than on there. So the pi's disappear. This 2 cancels with this 4 up here. That pi cancels. So cancel everything we can. Okay. So that means then that 2/3 is equal to y over 360 times the radius. Okay, so let me think about that. So 2/3 equals y over 360 times the radius. But we know the radius, don't we? I don't even have to write it as a letter. We know that the radius is 8 because we're given that. Okay, so we can simplify that even further. What's the easiest way of simplifying? Because we can work out what the angle is. Let's cancel that into 1. Cancel that, so that's 180. Okay. So that then means, let's bring this over here. So 8 times 3 is 24, so we get 24y divided by 360 still is equal to 1. So a little bit of rearranging here. So y is equal to 360 divided by 24. That's going to work out nicely, isn't it? Divided by 24. And if I'm not mistaken, that is equal to 12. So we've now worked out the angle of our sector there. So that's going to be 12 degrees, like so. And now the area of the sector is k pi centimetres. Okay, that should be easier to work out. I might have to drag this down slightly. So k pi is equal to the angle, so that's 12 over 360. Now we're going to use the other formula times, a lot of things are going to cancel, which makes me happy, pi times the radius squared. The radius is 8, so that's going to be 64. Okay, this is going to fall out very nicely. So let's see what we can do here. Well, these two things cancel. So we get k equals 12 over 360 times 64. Okay. Well, I think I can just say that 12 goes into 12 once. Why is it not working? 12 goes into 12 once. This 12 goes into 360 30 times. I'm getting the right answer here. Okay, so then we get 64 over 30, which is equal to 32 over 15. Now, I really hope I've got the right answer there, because that doesn't simplify any further. So I'm saying it's 32 over 15. What does the mark scheme say? 64 over 12, right? What have I done wrong there then? 4 pi over 3 by... Right, let's have a look. So I've done this. Okay, but why x over 360 and y over 360? Let's have a look at this. This is a problem when you start writing it as text and then start trying to do it normally, so to speak. Four pi over 3, area of the sector is OAB is k pi. I don't see what I've done wrong immediately. 64. 12 goes into there. 30 times, I agree. Okay, maybe y is not 12 degrees. I'm thinking there's the error. Y to the 360 times pi times 8 squared. Yeah, I got that. Why are these different though? I don't understand that. The angle doesn't change. Alright, I'm going to have to think about that one. Well, I'll stop the video for the moment, and maybe I'll do an update on that particular question there. But the idea seems right, but I don't know what I've done incorrectly to get that. I'll have to think about that. So 4 pi over 3, the length of the arc is y to the 360 times 2 pi times r. 2/3 equals y to the 360 times 8. Maybe I've done some operation wrong here. So 1/3. That's the problem. So what we've done here, this is still 180. So this is 180 here. So this is also 180. And then 24 times what gives me 180. 24 times 5 is 120. I'm assuming 15. So maybe this needs to be 15 degrees. 180 divided by 24. Six. No. Okay, so that needs 180. 180 divided by 24. So let's quickly work that out. So 48. 24 times 5 is 120. Maybe that doesn't go in nicely. Yep. Oh, alles fertig? Ja. Perfekt. Und nächste Woche was machen wir? Ja, genau, Dienstag wie normal. Ja, okay. Dankeschön. Dankeschön. Ciao. Right, this problem is not going to defeat me. Let me have a look. So 24y over 180 equals 180 divided by 24. Yeah, maybe that's just not a nice number, what comes out of that. Or just leave it as something over here. So, okay, well there's only one thing for it. Let's just do a bus stop method. So 24 into 180, like so. 24 over 180, so 0, 0. I need to do some multiples of 24. Let's try 24 times 7, that's going to be close. So if I do that, I get 8, carry the 2, 1,468. Maybe this just doesn't go in nicely, which is perfectly possible. Okay, but that doesn't really matter. Let's get rid of this then and put this in. So instead of that, I'm just going to put in that calculation of 180. Get rid of that now. 180 divided by 24. So what about if I just pop that in instead? That might be helpful. Okie doke. If I put that in, it seems like a big number though. Because this just comes to the top. So if I rub this part out now, okay. Let's get rid of this. Get rid of this. Okay. And there should be some simplifying that should make things a bit easier. So we get k equals 360 times 180. Get rid of that. Over 24. This looks like a mess though. Times 64. Okay. But I don't think that gives me the right answer by any means. Yeah, that simply doesn't give me the right answer. Right, I'm going to stop there with the video. I don't know what's going on in that question. That seems odd. That hasn't worked out as it should. Got the RKB, work out the area, and then work out K afterwards. So I'll stop it there. I'm sorry about the last question. It shouldn't have been too difficult at all when I first looked at it. But I will have to do an update maybe to the video. Hopefully you found it useful anyway for the first 14 questions anyway. The 15th one didn't go quite as planned, unfortunately. Right, I'll stop there for today. Bye bye for now.